a fuzzy regression discontinuity model, the exam grade is not the sole decisive factor whether you're getting the scholarship or not. Maybe you have to be a certain age, so age affects the probability of getting the scholarship, or being from out of town affects the probability of scholarship. And in this case, we can use the cutoff as an instrument of the x variable. So the x variable is a dummy variable equal to 0 if you did not get the scholarship, and equal to 1 if you got the scholarship. But what you can do is to explain this, the actual scholarship based on the exam grade. So if Z is based on the exam grade, and Z is 1 if the exam grade for person I was above 75 or equal to 75, and it's 0 if it was below 75, then we use Z as an instrument to estimate the random part of x in order to explain the y variable, which was the earnings. In this first step, you have the x variable, which is the dummy variable for whether you got the scholarship, then it's 1, or did not get the scholarship, then it's 0. And the Z is the dummy variable that you have made based on the exam grades. So if the exam grades in the W is below 75, then Z is 0. If the exam grade was 75 or over, then Z is 1. And W is, of course, the exam grade. So if you run this regression, then you would get the fitted probability of the x, or not the fitted probability, but the fitted value of x, and you would get an intercept, and the coefficient, the fitted coefficient on the z variable, and you would get a fitted coefficient on the exam grade variable. So this is the fitted value, and these fitted x values you would use in the second step. Now in the second stage, then you use the fitted values from the previous regression, and these fitted values, they should not be correlated with the population residuals. So now you would get an unbiased, or hopefully unbiased, estimate of the beta 1 coefficient, which is the causal effect of getting the scholarship on future earnings.